GIS or Geographic Information System. We are taking the MCQ based question and answer, helpful for your interview, viva and other examination. GIS stands for. Now the first option is Geographic Information System. The second is a Generic Information System. Then we have the Geological Information System and a Geographic Information Sharing. What do you think? What is the correct answer? Yes, you guessed it right. It's Geographic Information System. Now this Geographic Information System, first thing is it's not Geographical Information System or Geographical Information Systems. It's just Geographic Information System. Now let's go a few years back. In the bank, you used to go, the teller will write something, there will be no computer, there will be no electronics. But right now we use UPI, online transaction. We have an app for it. Similarly, geography also has evolved. Previously the maps were on papers. Now we have them on your desktop or on your mobile. That is the Geographic Information System only. So this Geographic Information System, now understand it like this. Now everyone has a mobile. They carry a mobile. So this mobile is nothing but a hardware. It has a operating system. So this hardware is a hardware. Operating system is a software. But in order to work, that is, you need some app. For example, you need Google Maps to navigate. So that is an app from Google. So Geographic Information System is a combination of various things. Hardware, software, humanware, dataware. So in this GIS, which is a computer system, we are talking about analysis and display on workstation, on computer system, even on your mobile. So GIS is nothing but a software. But why can't we just talk about software? We have to talk about hardware because we are dealing with different kinds of data and we are dealing with geographically referenced information. This geographically referenced information is also called as spatial data, right? Now you have taken a photo in your home or in front of your home. You want to actually align it with world. That is, the photo has to fit on the globe if you see it on your screen. So that particular location should be known. That is, the information, spatial information should be available on your photograph so that when you put it on the globe or a map, it should fit directly at that particular location. So that image having latitude, longitude and elevation and etc. information is geographically referenced information. So GIS consists of integrated computer and hardware as well as the software, because we are dealing with huge imageries, huge maps, huge data. So we need to have the analysis and display property. That's why we need a very good hardware with a good GPU, with a good processing power, with good display thing, and of course a software. All the content in the geographic content should be handled properly. So this GIS system is nothing but an input-output system. That is, the output is various data along with your map and images in different form and different kinds. It can be text data, it can be image data. But input is what? Raw data. So the system which is taking this input raw data and converting it to a meaningful, say for you or for your government or for your industry, this is the GIS. That is why it is called GIS. That is, you are having say raw data from the satellite. Now you are adding certain content with it. That is the metadata, the information about your data that is going to be combined. So in remote sensing also this is humongously used. So this data is inputted to a GIS. The processing is done, and that processing is done by the hardware and software. And finally, these all storing, managing, analysis, editing part and output part. This all is the first to last stepwise explanation of a GIS system. It's just not one thing. So you have to have that data, and then you are able to do all those things that GIS gives you the ability of. And finally, the visualization of geographic data. See, this all is a geographic data. Geo means earth. So we are talking about the data which belongs to, which pertains to earth, and whatever data, whatever image, whatever say metadata you take, it will be corresponding to geography. GIS deals with which kind of data? Numeric data, binary data, spatial data, complex data. So what do you think is the correct answer? The answer is spatial data. By the way, all the answers are correct, but we have chosen the best answer, which is spatial data, because numeric, binary, spatial, complex, all the data are there in GIS. What is a numeric data in GIS? Now let us take an example. In your class, in your grade, or in your university, say grade, you have some students. These are the age of those students. 23, 25, 27, 23, 25, 28, like this, random. So this is a statistical data. Why it is called statistical data? Because you can tell which one of your class is having the highest age, which one has the lowest age, what is the mode of that number. 23 is the mode. So mode, median, all this you can take it out. So this is a statistical data with having a geographical component. Now this number doesn't pertain to geography. But when you say this is a class, you say that this is a class based in say some university in Chicago, and this is the location of that class, that grade, that university. So that is how the geographical component is added to it, because now you are having the latitude, longitude, the spatial space information in it. And now this data can be displayed as a layer on a map. So you have a map on a background, and as a layer of these numbers, you can show it, and then you can join with vector files, and this can be queried. Now you want to use this data and apply it as a vector file. What is a vector? Vector are point, line, polygon in order to represent different geographical features on the map. So these are the all students of your class. Now how do you relate it? How do you make it on a map? You cannot place people. You will just place some point, and you will write a legend, L-E-G-E-N-D, that these dot represent people in my class. Alright. So just query on it. How many kids are above 25 years of age? How many of them are below 23 years of age? So all these can be queried on this vector file, which is a point vector file here. Now let me give you an actual example here. Demographic data from country's census. Now this is an example of Indian region. Now how do you know, and how are you going to represent this numeric data and use this numeric data? So this numeric data, when the census is being taken, you can now see which are the places where the population has grown exponentially, and which are the places or regions of India where the population is low. So all this area which I just bounded, there is a lot of population now, and these area the population have not grown that much. So there is a control of population growth. So this is how the demographic data from any country's census can be showed on a map, and with a just color combination you know that what is the information, which area has more population. What is a binary data in GIS? Even if you don't talk about GIS here, binary data just means yes, no. Now how this yes, no, 0, 1, completed, not completed has come? It has come from by. B-I, by. By means 2. They're like try means 3. So this is how binary has come. So there must be some question, there will be some question in any field of science where the answer can only be in yes and no. So in GIS, binary data is stored in ones and zeros. So if you have a switch, you make a switch on, it will be 1. Switch is off, it will be 0. In your home I'm talking about. So this binary data can be used in GIS in order to represent two discrete different categories. Or if you have some question which can only be answered in yes or no, approved or not approved, completed or not completed. So this will be binary data. So let me give you one more example here. So if you have an image and that image is only black and white. So this is a raster image. So this will always be in the tabular form. That is, you will have grids here. So these blocks which I am actually making a kind of black, like covering it. So all these black spots, or the blocks which are actually covered, you can write it as 0, and all those points or all these blocks where there is no, there's a plane which can be called as a white, so it will be 1. So this is how 0 and 1 can be placed for a black and white image. That's it. That is how binary data is being done. Now this is an area. Let's take another example. And these are housing. So we are planning to make houses now. So you can say completed and not completed. So maybe this house is not yet been made. So you can make it as 0. Those houses which are being made, completed, fully ready to enter, they are 1. Again, when you went to the authority to approve it, the map can be made that these houses are approved or this area is approved, this is not approved. So that is how the binary data in GIS work. This is an example of actual images I am showing. For example, BIL is a band interleaved. So here this binary data is immensely used. In GIS, the most important and the only data which is taken up by GIS is spatial data. So the GIS deals with spatial data. Now spatial has come from space, word space. Space means area, location. This location, any data having location information. For example, if just you say that I'm standing somewhere, nobody is going to catch you up or meet you up. When you say I'm here and I'm there, nobody is going to know where are you. But when you say I am on this street, corner of this street, right corner of this street, or the intersection somewhere, you call it that I'm at that intersection. Yeah, now you are giving the spatial information to the other person. So this spatial data or geographic data or geospatial data are same. They have the same name. And it provides the information that identifies what? The location of features. Anything on the earth are called feature. Like you have trees, they are feature. Like you, cars, the river, they are all features. So the location of features and the boundaries on earth. For example, this is an Indian map and I'm just saying that one of the state is Rajasthan. Now this Rajasthan has a boundary. Now this boundary on the world map, everyone will know that this is the boundary, this is the lat long information of this particular state. Where is Gujarat, where is Rajasthan and where is Haryana? You can know it by the area, the location of the earth. That is the spatial data. So spatial data can be processed and analyzed using geographical information system and also the image processing packages. Anytime you want to process a data related to geography, you need to have the spatial information, the location information. So let us take an example here. Now location of features means what? So you are here, you are also a feature. Standing near a tree or standing near a street, that is also a feature. And these all features are only valid in GIS when you have the spatial information, location information. Alright. So the land use, the land cover, the tree, the river, the mountain, the buildings, all are spatial data in GIS or image processing packages. In GIS, what are the complex data? See, in GIS, normally we deal with this spatial data, but all that can be easily more categorized in numerical data, binary data, complex data. Because spatial data is a bigger word for those which are having data with having location information. But complex data is about the large and complex data sets, and these should be spatially related. They should have a spatial information. For example, we have a satellite. It will give you some satellite image. For example, let us take the example of a quick bird or Icono satellite image. Now they give us the 11 by 11 kilometer of area, one shot, one image, one patch is 11 kilometer by 11 kilometer. Now the lowest area which can be seen, for example, a car can be seen. So when you see a car, you can imagine how big that data will be. If it is 11 kilometer by 11 kilometer, 1 meter resolution, you will have at least 2 GB of data. At least 2 GB of data. Now this 2 GB data is just 11 kilometer by 11 kilometer. If you have an area, say 200 by 200 kilometer, you can imagine the size of the data. So this is a high spatial resolution data and it has multiple attributes. That means the data about the data, metadata. What are the attributes? What does attribute means? See, there is a person. Now you have just written the name and the age of that person. This is the enough information to know about a person. But if we extend this attributes or the fields or the metadata of that person, age, gender, location, say the blood group and everything, whatever is possible. So when the attributes will become humongous, it will be called as complex data. And more important thing is the data from where it has come, the lineage, that is the diverse data. For example, if you now want to know the education, if this guy is a B.Tech, is an engineer, from where this data might have come from, some dynamic or some different diverse sources, and the dynamic changes are that the age is say 25 when the data was being made. Now after 2 years he will be 27, or say after 1 year he will be 26. So there should be a dynamic change, and those data which need some dynamic changes are called complex data. And what is the thought about this complex data, which we need to know as a GIS people? That handling such data can pose challenge for storage, because the data are complex, big, humongous. In order to process, you need GPU and very good, you say, i7s or Xeon processors. Analysis for that complex data, because it's a complex data, there should be some very, very learned people to understand what is exactly going on, and visualization. Because all is about visualization. What you cannot see, it's difficult to perceive. So you just imagine, I was talking about 200 kilometer by 200 kilometer area. The amount of data that needs to process, analyze, visualize is humongous. That is why this is called as a complex data. By spatial data, we mean data that has, first is complex values. If we have complex values, it is a spatial data. We have a positional value that can be called as a spatial data, or graphic values that can be called as a spatial data, or the decimal values. For example, we have points in the numbers. What is the answer? What do you think is the answer? Yes, it's correct. It's positional values, right? Spatial data means positional values, location values. Now, GIS starts with positional values. Positional values, and positional values means the information about your geography, the information about your location. For example, if I am standing somewhere, where am I standing? What is the location of myself? On what street, on what point on the earth, the globe I am standing? If I say I am standing in, say, some street, say Romaine Street. Now this Romaine Street is in Canada also, in UK also, in Australia also. So when we say I am standing on Romaine Street of Ontario in Canada, then people will know, oh, you are talking about that thing. These are positional values. So when you put yourself on a map, you will put a dot. That is point data. What is a point data? The point data represent distinct data points on non-adjacent features. Alright. Now just understand it with an example. Now, if you want to tell people that how many hospitals are there in your city or a country. Now, this is a bigger canvas now. You're talking about a bigger area. So you will put a dot. That is, even if you are asked about schools or cities or point of interest can be your say play field. It can be all the dustbins or garages in your area or bigger area. So all these points can be written or can be represented as dots, and which are nothing but the point data. So the point has no dimension, is just a dot. So it's zero dimension. There is no length, there is no area of a point, because it's just a dot. But when you come to other feature, say it is called a line data. There is a road in the map which we are making, and there is a railway line also. So this road and the railway line, these represent a feature, and this feature can be rivers, trails, or streets. I have given two examples of road and a say train route. So there is a start and end. In line data, there will be start and end. And since it is a line, or it can be a curve, means a straight curve or a bend curve, it can only be used to measure length. The road from X point to Y point, or A point to B point, the length can be measured. But there are certain features which can be polygon data also. Now this hospital was, if the picture was bigger, the area was bigger. But when you come to a very small area like your colony or the place where you are living, the neighborhood, then you will just mark a bigger, say a block for representing a hospital. If it's a very big map of a country, you will just put dots. But if you're talking about just your neighborhood, you will place a block here and say a water body is there. Then you will mark it using a polygon. So polygon here is a GIS object that stores a geographic area as a series of X and Y coordinate pairs. For example, these are dots which we have made, and they will have some X and Y, that is the location for that Cartesian coordinate system which we assume. So this is x1 y1 coordinate, this is x2 y2 coordinate, the other will be x3 y3, then the next one will be x4 y4, and again the final point x1 y1 and x5 y5 will match. So now when we have region, we can measure the area, we can measure the perimeter, that is the length of the boundary. So this area of a hospital, the area of the water body can be computed because it is a polygon data. What is a metadata? Now the options are, it is data about data. The second option is it is a meteorological data. Then we have the oceanic data and the contour data. So what do you think is the correct answer? The correct answer, of course, you got it right. It's data about data. So the data which actually gives information of certain other data is nothing but the metadata, and that is very important. You'll understand just now. So metadata is the data that describes, define, give more information about other data. For example, my name is Adam. Now this Adam can be in Canada, it can be in UK, it can be in Australia, even in India also. Adam can be anywhere. Now if Adam says I stay in Delhi, New Delhi, or there is another Adam saying I am in Chicago or Canada. So now this, you can identify this Adam is from Delhi or Canada. Now there is some more information added. One Adam age is 25, the other's Adam age is 35. Now you have more information about Adam. So how the information getting added describes the man. So man is a data, the Delhi or age which we have written is the metadata of that data. So this geospatial metadata, it describes and defines various things. Please understand, a map without added information is nothing. A GIS file is just a raw file if it doesn't have the added information metadata or an imagery or the location based data resources. All these are defined only when you have a geospatial metadata, that is the data about these data which describes or defines it more. If you just give a map to someone, they will not understand. You have to ask what is the projection of the map, what is the datum of the map, from where the data has come, when it was taken, what is the quality of the map. All these are the metadata information. So GIS metadata, it facilitates, it helps of integration of disparate data sets. For example, a data is created by someone in Toronto. The other data is created by someone in Calgary. Now these are two different data, but in order to go on a broader view of understanding a country, these disparate data needs to be integrated. For example, in terms of Canada, these two both come in Canada. So promoting the interoperability between different GIS data sets, different software. For example, if you make something in Ilvis, want to take it in ArcGIS, you ought to know the metadata, then only the ArcGIS will address it or accept it in a certain form. So data is just not like a raw data, it also had to have the added version. An added version are nothing but the metadata. This GIS metadata also helps in data sharing, and as I just gave you an example, different GIS platforms and users will use it, might use it. Alright. So this data, like from which satellite it has been taken, what is the resolution of that data, all this information is nothing but metadata. Key components of spatial data quality include, the options are positional accuracy, temporal accuracy, lineage and completeness, and finally the logical consistency. All of the above. What is the correct answer? Wherever this all of the above will come, mostly you can go with that. This question also says all of the above, because spatial data, any data should have quality. Please understand what is the quality. Now you went to a shop which is open shop, there is one person making it, okay, not actually built, someone has just started it. It's tea, what kind of water it used to make a tea, whether this guy is clean or not. He is giving you the tea in $5. But if you go to a established tea corner or coffee corner, the tea may be of $50. but the water they use is clean. Okay, the content they use is already quality checked, like the sugar, the coffee or the tea or other ingredients. So this 50 you are giving just for quality. So this data quality, especially related to spatial data, is all about the completeness, the logical consistency, the positional accuracy, the thematic accuracy, temporal accuracy, and the usability. All these are the parameters. We'll just talk about them in just a bit. But let us understand the spatial data quality is all about the assessment and evaluation of the accuracy. How much we can rely on the data of GIS. Can this data be used in geographic information system? Are they fit to be used? Can you give it to someone so that he can make or she can make any decision? In the context of GIS and digital data sets, spatial data quality is all about accuracy, reliability, and fitness. Alright? So if we have checked our data with certain rules, regulation, and parameters laid down as per the quality, if it passes it, then only the data can be used. So 7 elements of spatial data quality. Just understand one by one. First one is the positional accuracy, attribute accuracy, completeness, logical consistency, lineage, semantic accuracy, temporal information. Okay. Now, just by saying this will not work. Let me explain it to you. So these are the 7 elements of spatial data quality. So in GIS, we are trying to put a map and we want to add certain GPS coordinates along with this. So these GPS coordinates on a map, what is the positional accuracy? Now you have to tell this GPS data whether it is 10 meter accurate, whether it is 20 meter accurate, and this is the positional accuracy. How about the attribute accuracy? Now attribute is all about the metadata, that is the information about the data. What are the attributes? For example, the map. Okay. Now, what is the size of the map? What is the location of the map? What is the location of the places which are being showed in the map? If the location is shown 28.3 and 78.6, when you put it on the globe, it will not go there because the actual area is 27.3. So there is a change. Someone has written 28.3 in place of 27.3. So this is attribute accuracy or inaccuracy. Completeness means everything is filled or not. For example, there are 4 points. All the 3 points have all the information. The 4th point is missing certain information. So we will say that this quality has failed. The data has not complete information. Alright. All these, understand it like this. There are 4 people. 3 people name has been written. 4th person name is not being written. So you'll say this is incomplete. How about logical consistency or logical inconsistency? Logical comes with the logic. That is, it's yes or no, true or false, like that. So somebody says that this data which we are trying to input, the data is shown of Africa, but it looks like a data of Antarctica. That is illogical, no? How about the lineage? From where it has come? Now this data has come from where? This data has come from Iconos, from QuickBird, that is the lineage. Now semantic accuracy. Let us go through the names first, because for example, someone has told you that my name is Amit. Now you have written AMEET and he comes to you and say, no, it is not AMEET, I am AMIT. So that is semantic inaccuracy. Temporal information is all about the time. Somebody comes and gives you a map, says it's 2007 map. You already know it's 1997 map. So there is a temporal information mistake. Alright. Temporal is all about time. So these are 7 of data quality measures. Spatial databases are also known as geodatabases, mono databases, concurrent databases, and none of the above. What is the correct answer? So spatial databases are geodatabases. The correct answer is this one. What are geodatabases? Now, geodatabases, the name is coined by a very good company. First, understand geo is earth. It's globe where we live. Now, this has come from, geodatabases has come from ESRI, geodatabase. First, let us understand this GIS database can be divided into spatial database and non-spatial databases. Databases which will have the location information, and that will be the data structure in which the data will be put will be raster and vector. Vector can be point, line or a polygon. When it comes to a non-spatial database, this is how the database is being structured. That is, it is in the table, relational, network or hierarchical. So geodatabase is coming from, it's actually a proprietary GIS file format, and it is developed by ESRI to represent, to store and to organize the spatial data sets. It's nothing but geodatabase is the database name from ESRI. Now you can understand that ESRI is the Shah Rukh Khan of film industry. You know Shah Rukh Khan, he is worldwide famous. That is why the ESRI is the Shah Rukh Khan of GIS industry. So whatever word they coin, they are with people who are in the GIS field. They learn it, they understand it, and they have to know it that geodatabase is a special database from ESRI. So we have just talked about the introduction to GIS MCQ question and answer. I hope you'll be benefited. Thank you so much. Have a good one.